this will be the introductory video to the topic of voltage. So you watch this video first, and I discuss energy and circuits, and then we move on to that, to the idea of voltage, which is connected to this. So take you back to first semester. Energy is what? What was the definition? So you might want to pause the video and think about it or write it down, right? Energy is how much work a thing could do. How much work. So energy means the ability to do some kind of work. Well, what's work? Again, pause the video. Can you write work equals, or work is defined as 3 lines. Okay? Work is defined as force times distance. So we have a certain amount of energy. Whatever has that, we can get a certain force applied on something through a certain distance. So the idea of energy kind of takes on its own realism, and we can just talk about it, and it makes a lot of sense. What it means in English is a lot like what it means in physics, so there are no problems there. Okay, but this is about specifically energy in circuits. So here's a circuit, battery, wire, light, and a motor. And the motor here is turning a propeller. So you think of this propeller as spinning. Okay? Now we're going to look at what happens with energy. And we're going to use one of those analogies. The charges are moving through the circuit like this, kind of like cars with gasoline in them, and each charge, we're going to think of it as a clump, each charge has a certain amount of energy. It comes out of the battery, and I'm going to draw it like this. These are charges coming out of the battery, and by charges, I mean each of these is 1 coulomb. Think of it as 1 coulomb of charge. And it's got a big smile because it's just come out of the battery and it's gotten energy. And as they move through the circuit, the reason they're smiling is this charge has electrical energy. That's the type of energy that's in wires. Okay? Then the charge goes through the light. And as it goes through the light, it gives up some of its energy. And so when it arrives here, it doesn't give up all of it, but some of it. It now looks like that. Okay, and that means there's been an energy conversion at the light. So see if you can think of what goes in the blanks from first semester. What type of energy was in the wires, and it changes into what type here. Okay, you might want to pause the video. All right? So as the charge has electrical energy, so the type that gets smaller is electrical energy. And then a light, of course, gives off light, so that it gets converted into light energy. And with the type of lights we used in our lab, you can also add and thermal, because the lights get a little bit warm. That's why they glow in the first place. So light energy and some thermal energy. The charges keep moving through the circuit. They don't lose all their energy here. That's not possible, because of what a battery does, which we learn more about later. They go through the motor, and the motor turns. So think about what type of energy changes into what type. You might want to pause the video and think about it. Okay? What happens is the charge is losing energy, so that means electrical energy is getting smaller. And this is a spinning propeller, which means what type of energy? Kinetic energy. So it changes into kinetic energy. Right? And then what am I going to draw here? Again, you might want to pause the video, look at the pattern. The charges have a lot of electrical energy, then they have a moderate amount, a medium amount, and then what are they going to look like here? They're going to look like this. Because we talk of them as being out of energy. They have no more electrical energy. And they can move along a wire because in our simple model, wire is free. It doesn't cost any energy. It's like gliding in a car when you're out of gas. Wire is free. That's our simple model. And so the charges go through the wire, approach the battery, and this is how they enter the battery. And now think about what we learned in the first semester. What kind of energy is in the battery? So what conversion is going to take place in the battery? Why do they go in like that and come out like that? Pause the video. So when they go through the battery, they come out with electrical energy. So they've gained that. So we've gotten some of that created, electrical energy. But what kind of energy is in a battery? Think about it. It's chemical energy in a battery. And so that's what a battery does. It has a chemical reaction, and as it loses chemical energy, it gives that energy to the charges in the form of electrical energy, and this repeats, and it keeps going around and around and around. One last thing I'm going to add for future electrical engineers or future engineers of any type, or just if you want to know it completely. In reality, wire is not actually free. So that's why we put free in quotation marks. In reality, and we'll add reality down here, in reality, what you actually have is electrical energy changing into, think as charges go through a wire, there's some collisions and contact. So what type of energy is being produced? Think about that for a minute. By that friction, okay, there's a little bit of thermal energy being produced in all wires. And this is very small in the wires that we use in any labs. And in the online circuit lab you do it, the wire is initially modeled at having no resistance and there's no energy loss, but you can adjust that in that online lab. So that's the approximation we use, that wires are free, but in reality they're getting slightly warm. Now if we put a really, really big battery here, like 100 volts, what's going to happen to this wire? Or 10,000 volts, especially if it's short-circuited. Pause the video and think for a minute. Okay, what will happen is the charges move so fast, there's so much through that resistance that you're getting a lot of this, and the wire will get extremely hot enough to start a fire.